Today we're going to talk about solving literal equations. A literal equation is just a formula, an equation with more than one letter in it, as you see some here. If you think about it for a minute, you probably know many literal equations, like this formula here deals with accumulated value, principal, rate times. This is a formula for interest. Y equals mx plus b, that's a famous one I'm sure you've seen many times. This is the formula for converting between Celsius and Fahrenheit, so on and so forth. Area equals length times width. Area equals 1/2 base height. All sorts of formulas that you know. Now very often we're given a formula, such as this one, and we would say this formula is solved for A, which means I have A all by itself on one side and a bunch of stuff over here with no A's in it. And what we want to do is we want to rearrange it and we want to solve for R, which means we want to take this formula and we want to get R all by itself on one side with a bunch of stuff on the other and no R's on this other side. Now, when there's a lot of letters, that tends to confuse people. What if, I'm going to change it a little bit, what if we had A equals 5 plus 5 times R times 2? And of course we would probably write that as A equals 5 plus 10R. When I give students an equation like this, they generally have absolutely no problem getting the R all by itself. They would say we subtract 5 on both sides. So we have A minus 5 equals 10R, and then to get the R all by itself we divide by 10. Well, the truth is, it really works exactly the same way when you have a formula, and that formula has lots of letters in it. We're trying to get this R all by itself. So we look to see what it's connected by. It's connected by some multiplication, and it's connected by addition. When we're solving equations, typically we do the adding and subtracting first. So to solve this equation for R, I subtract P on both sides. Just like back here, I started by subtracting the 5. Well, the big difference is, we just have lots of letters. We can't ever combine any like terms. So we have A minus P equals PRT. And then again, I'm trying to get this R by itself. It's now connected by multiplication. It's multiplied by two things. No big deal. We divide by two things. So the answer would be A minus P over PT equals R. And we would say that formula is solved for R. Solved for R because it has R all by itself on one side and a bunch of stuff over on the others. Alright, I'm going to skip down to 4, but you're going to do 2 and 3 for homework. I'm skipping down to 4 because it's got that fraction, and that fraction tends to upset people. What I would do on 4 is I would begin by distributing. So I would write this as C equals 5/9 F minus, I think of 32 as being 32 over 1. I multiply tops, multiply bottoms. I get 160 over 9. Alright, so fractions. And again, fractions tend to bother people. They shouldn't. If you have an equation, and that equation has fractions, what you're going to do is you're going to take that equation and you're going to multiply every single term by the common denominator. The common denominator is 9. Now notice I need to multiply over here, even though that one doesn't have a fraction in it. I still have to multiply everything. So 9C is 5F minus 160. Alright, well now that the fractions are gone, it's pretty straightforward. I add the 160 on both sides. 9C plus 160 equals 5F. And then finally, I divide by 5. And I could write my answer a couple different ways. I could write F equals 9C plus 160 over 5. What I cannot do is take the 160 and divide it by 5 directly. This big fraction bar tells me I have to divide everything by 5. So I could write it this way. I could write it as 9/5 C plus, and then I take the 160 and divide by 5. The big thing there is, remember, if you're going to divide the 160 by 5, you also have to divide the 9 by 5. That's 9/5 C plus 32. Okay, so those were basic ones, and those are ones that do not require factoring. Now let's look at ones that do require factoring. The big difference is when you look at your formula, and it says I'm trying to solve for pi, and I see 2 pi's right there and right there. When you see, if you're trying to solve for a variable and you see 2 of them, that tells you you're going to have to use factoring. Alright, so first I'm going to do this the right way, and I'm going to show you the wrong way, a very common mistake students will make. I'm trying to solve for pi. I see 2 of them. So I'm going to factor that out. I'm going to factor out a common factor. I'm not going to actually use the greatest one. Since I'm trying to solve for pi, I'm only going to factor out pi. I could factor out more, but I don't want to because I want to get the pi. So that's 2r squared plus 2 pi, 2rh. So notice there was more stuff common, but I did not factor it out. I only factored out the pi. And the reason for doing that is now I have pi being multiplied by something. To get the pi all by itself, I just divide both sides by that something. So my answer would be a equals 2r squared. Pi equals a divided by 2r squared plus 2rh. So notice I have the pi all by itself on one side and no pi's over here. Alright, so now let me show you the common mistake that students make, and they do this wrong. They do this. They start with a equals 2 pi r squared plus 2 pi rh. And they start by subtracting 2 pi rh on both sides. So they have a minus 2 pi rh equals 2 pi r squared. So then to get the pi all by itself, you divide by 2r squared. So answer is pi equals a minus 2 pi rh divided by 2r squared. Now, the reality is you haven't made any algebra mistakes. In that sense, you haven't done anything wrong, but you haven't solved for pi. When we say solve for pi, we mean have pi over here on one side and then don't have any pi's over here. So notice we have a pi over here on this side, but there's a pi over there. So this is not considered solved for pi. Okay? So, again, the big thing to look for, if you're trying to solve for a letter, or in this case a Greek letter, and you see more than one of them, you're going to have to factor. Alright, so let's take a look at number 2 here. Number 2, I want to solve for h. And I notice that I have a couple of h's. Alright, but before I can factor, I think I need to do a little distributing here. Get rid of those parentheses. S equals 2lw plus 2lh plus 2hw. Alright, so what I notice is I have 2 pieces that have h on this side. Unfortunately, I also have a piece on this side which has an h. So I can't factor h out because h is not common. So what we do need to do here is we need to set this equation up so that all the h's are on one side, but all the stuff without h is on the other. In other words, I need to subtract 2lw. I got to have all the h's on one side, all the not h's on the other. S minus 2lw equals 2lh plus 2hw. The reason I want to do that is now that this side, all the terms have h in it, I can factor that h out. So I'm going to have s minus 2lw equals h times 2l plus 2w. And again, I could have factored out more. We're not taking out the greatest common factor here. We're just taking out a common factor. The a common factor is the letter h. So finally, to get h all by itself, I divide. Final answer will be h equals s minus 2lw divided by 2l plus 2w. Alright, a couple more for me. Actually, one more for me and then 3 for you. Problem 3. Again, problem 3, you'll notice it has lots of fractions. Don't let lots of fractions freak you out. We're going to take 1 over f equals 1 over a plus 1 over b. We're going to find the common denominator. Well, the common denominator, we need an f, we need an a, we need a b. So I'm going to take every single piece, I'm going to multiply it by f, a, b. When I do that, that f reduces with that f, so I have ab left right there. That a reduces with that a, which means I have fb. And finally, that b and that b, which means fa. Alright, now what I notice is I'm trying to solve for b, and I notice I have two things that have b's in them. So we got to do like we did last time. When we have two things that have b's in them, we want all the pieces with b on one side, all the pieces without b on the other. In other words, I need to subtract fb on both sides. ab minus fb equals fa. Now the important thing is on the left hand side, all the pieces have a b in them. Since all the pieces have a b in them, that's a common factor. I take that out. I'm left with a minus f. And finally, to get the b all by itself, I can divide. And there's my final answer. Alright, so for homework, you're going to do these last three. And for all three of them, I would suggest you begin by multiplying by the common denominator and getting rid of all the fractions. Not much of a common denominator here, it's just a number 2. But multiply by 2, get rid of that fraction. This one, multiply by b and x, and make sure you do it on the right hand side, even though that's not a fraction. And this one, multiply both sides by 1 minus r.